Hi there, welcome back to Pretty Much Falls. Today in this video, we are going to be looking at the basics of transistors. Let's get into it. So, a transistor is basically a three-terminal device that can be used for a switch, an amplifier, or a potentiometer. So I have a circuit all wired up here. And as you can see, the LED's on, and we're using the transistor as a switch. So, we can see here that we have our switch turned on. It goes through this resistor. You normally want a resistor before hooking onto the base of a transistor, because this can happen. So another way you can also burn out your transistor is exceeding the voltage limit between the collector and the emitter, also exceeding the current limit between the collector and the emitter. That's a few ways you can burn out your transistor. It might not physically burn, it might just cook itself inside, but yeah, you don't want to do that. And that current goes into the base, and so now that the transistor is turned on, current can flow from the positive to positive through the collector to the emitter, and through the LED back to the negative. So that's how you use a transistor as a switch. So far we've just been talking about the NPN transistor, but there's another type of bipolar junction transistor called the PNP transistor. So here's the similar circuit to the NPN transistor. It's just this time the base has to be made negative in order for the transistor to start conducting. You can see that. So that is basically how you use a PNP transistor. Very similar to an NPN transistor, only the base has to be made negative in order for it to start conducting. So right now we're using the transistor as a potentiometer. So right now we're varying the current and flowing into the base by using this potentiometer right here. And you can see the LED gets dimmer or gets brighter when I adjust this. So hook this onto the negative. There you go. And now we can do some probing around. So on the input here, we have about 2.9 volts. And on the output here, we have about 2.4 volts. So let's turn this up. Oh, that's going down. So if you're wondering why it's 2.4 volts, there is a certain voltage drop across the transistor, because you don't get something for nothing. There's about a 0.6 to 0.7 voltage drop from the collector to the emitter, so that's what we're seeing there. And if we adjust the voltage down, you can see we go all the way down to 1.9, it looks like. So if you were to use a bigger potentiometer, you could probably have a greater range right there, but that's using the transistor as a potentiometer. Now let's try using the transistor as an amplifier. We'll have to turn on the oscilloscope for this one. So this is a pretty chaotic mess of like oscilloscope probes and everything, but this is how you use a transistor as an amplifier. So we have current coming from our source here, that were our pulse source, and that goes into the transistor. And this LED is actually blinking very, very fast, more than you can actually see. Maybe if I slow down the camera, then you might be able to see it's blinking very, very fast. But yeah, so let's take a look at the oscilloscope screen. Alright, so now you can see the top one here is channel 2, the bottom one here is channel 1, and channel 1's input signal is about, let's see, it's 1 division, 1 and about half, 1 about quarter division there. So that is about 2.25 volts, so about 2.25 volts, and up here we have, let's see, that's one division and almost 2 divisions, so that'd be almost 4 volts there. So about 3 volts, 3 and a bit volts. So that's, so you can see it's using amplification, and you can also see here that this is a common emitter amplifier. We'll do a video on those later, but you can see that every time this side goes up, this side is going down. You can see that. And every time this side goes down, this side is going up. So this is a common emitter amplifier which inverts the incoming signal. Thanks for watching this video today. Hope you learned something. If you have any future video ideas, leave them in the comment section down below. I'm open to suggestions, and I'll see you next time.